Hello, good morning, and welcome to day three, I guess, the European is three, of DelphiCon 2021. I'm Jim McKeith. This morning, we have David Millington's session on using C++ to extend the reach of Delphi. Always learn a lot from David's sessions. He does a great job. So with that, I will turn it over to David, and he'll take it away.
Awesome. Well, thanks, Jim. We'll just turn on my camera as well, so that hopefully you can all see me.
I see you. You look great.
Fantastic.
Dapper
Thanks.
as usual.
All right. Well, hi everyone. I'm Dave Millington. I'm a senior product manager here at Embarcadero. Now, normally with these webinars, we try and pre-record them, but I'm doing this one completely live. So hello. Look, today we're going to talk about using C++ to extend your Delphi app. Now, for those of you who are wondering if this is familiar, I actually did a similar talk in 2016, 5 years ago now. But this time I'm actually going to show a bit more than that one did. I'm actually going to pull in an open source C++ library from Get and make use of that. So I'm going to show code that where you have an existing Delphi app and we end up using an open source C++ library with your Delphi app. So Delphi and C++ build are fairly rare in that they can interoperate at the binary compiled level. You can build a single application using source code in 2 languages. Now, before expanding on how to do that, I think it's worth asking why. Why would you build your app out of 2 languages? And a programming language is called a language for a reason. It's a way to communicate and to express intent. And the way that a language is designed makes some languages better for some purposes than others. Some are good at data processing, some at writing algorithms in, some at being easy to understand or to read, some at connecting to user interfaces, some at being efficient or performant, and so forth. And that means that you can choose the languages you use based on your intent. But the key is that you're not limited to one language and that you can mix and match languages based on your purpose at the time. So Delphi is an example of a language that's very clearly written. It's expressive and great for connecting to UIs and very easy to understand when you read it. Now, C++ is a language that's less easy to understand when you read it, but very good at performance, and it has a lot of open source libraries for a huge variety of functions. And mixing the two lets you write most of your app in Delphi, but bring in some of the C++ compiled performance or some of the vast number of C++ libraries that are available. So in this talk, we're going to see one technique to call into C++ from Delphi code. And the technique I've chosen is my personal favorite. I've chosen it because from the Delphi side, it feels very Delphi-ish. And we're going to use, as I mentioned, one of the open source C++ libraries and get it to speed up some Delphi code by rewriting it in C++. So before getting onto that, I want to show a little bit about binary compatibility. Also, I can see that macOS is sharing its dock and title menu bar at the moment, and apologies for that. I have no idea why, because it should be auto-hidden. Look,
actually, we don't see your screen right now, David.
You don't see my screen?
Nope.
All righty.
Now we do.
How about that?
Yeah,
we just went through a wonderful slide on choosing languages with different languages suitable for different purposes, and the slide just said that we're going to see how to call into C++ from Delphi app. This slide I think is really key though, and so I'm glad that that we have the slide visible for this. Look, the key with calling between languages is binary compatibility, and that takes a few forms. There's object file compatibility. For example, there are different formats of your intermediate compilation files. What the compiler emits goes to a file, an object file, and then that's linked into your final executable. For example, on Win64, C++ Builder uses ELF64. or the application binary interface compatibility. So I want to explain as well the difference between an API, an application programming interface, and an ABI, the application binary interface. So the API is the most common term, and that's the programming interface. And that's where you have a set of methods or an interface or something like that. And effectively, that's an interface that's defined for you, the programmer. It lets you know what methods are available for you to call. Or it lets you know some of the language semantics, that a method parameter is const and you can't modify it, something like that. The ABI, the application binary interface, is where things get interesting, and that's where things like calling conventions are defined. So you might have a statement like, any value type less than 8 bytes in size will be directly placed into a register, but if it's greater than 8 bytes in size, the register contains a pointer to its location. Its usage semantics are as a value, even if under the hood is accessed by pointer or reference. And now that would be an example of the kind of statement you might have backing the actual binary interface. And really what that is it's saying how the API is implemented under the hood. So the ABI is what means that these two APIs, you can see a method declaration on screen, the top line in Delphi and the bottom line in C or C++. So that those are one API expressed in two different languages, and the ABI is what means that they are the same. Which means that at a linker level, or when loading a method and calling it by its address, they are the same. The way the parameter is passed is the same, and so forth. And you can apply that to a whole class declaration as well, or an interface. Now, Delphi actually auto-translates Delphi APIs to C++, so it performs the translation that you can see on screen right now, obviously not just for methods, but for all type declarations, your classes and enums and everything else. And that translation is one of our studio's key features, and it's what lets us write components like buttons or an edit control or something in Delphi and have C++ developers use them. But we can also leverage it to help Delphi developers access C++. So you may be wondering if we can just write C++ code and have the compiler translate the API to a Delphi unit so you can add that to your users clause. And unfortunately, the answer is no. 99% of Delphi can be represented in C++, but not the other way around. C++ has many things that cannot be represented in Delphi code. But we can still use this Delphi to C++ translation to access C++. So here's how we do it. Well, one way to do it. This is my preferred way. First is we write an interface or an abstract base class in Delphi. Now, using the C++ translation, C++ builder can then implement a class that inherits from that Delphi class. And then in that C++ class implements whatever needs to be done in C++. And Delphi talks to the C++ code as though it is Delphi code using the Delphi interface that it knows about. So to run through that again, we make use of the compiler translation, and the same thing can be represented in two languages. To write an interface in Delphi, implement it in C++, and speak to it as though it was Delphi. Now, there are other ways to do it. You can flatten to a plain old C API, you can use COM, there are all sorts of things, but this is my personal favorite way because it makes use of the inbuilt Delphi C++ interop. And it means that on the Delphi side, you address the code as though it is written in Delphi. So that's sort of the theory behind it. But I want to actually, of course, go through this in practice. So I'm just going to turn off my camera now so that we can focus on the screen. Alrighty. So hopefully you can all see Rad Studio right now. Now here in the IDE, I have two projects. Now one is my existing Delphi app, that's the one that's selected right now. And I want to add some C++ to it. I'm going to do this by putting my C++ in a package. Now you can put it anywhere in a DLL. You can even put all your Delphi and C++ code together, .pas files and .cpp files in one C++ builder project, although it's not ideal if your app is 99% Delphi. But following from the idea, which I think is common for many people, that you have an existing Delphi app and you just want to add a bit of C++, let's quite literally do that. So we have a Delphi app and we're going to add a C++ package to it. I also think this is quite architecturally clean. So in my Delphi app, I'm going to define an abstract base class. So you can see that definition here. I have a T-abstract class. And all the methods here are virtual abstract. So this class has no implementation at all. It is very similar to an interface. And it has all the properties and methods that I want to use. And you can see how it has a property here and a procedure here, and here are the property getter and setters and so forth. Now I'm using an abstract base class as a type of interface since I can just inherit from it. Now, if you want, you can use an actual Delphi interface, and the compiler will translate that, so you can implement the Delphi interface in C++, but personally, I think that the abstract base class here is simpler. So first, let's have a look at how this would work using Delphi from Delphi. And then we'll do something very similar from C++. So I want to demonstrate the Delphi version first in order to make the C++ technique clearer. So in Delphi, we can inherit from this abstract base class. So I have a Delphi implementation unit here. And you can see I have a T-Delphi descendant. Actually zoom in the code a little more again. Delphi descendant that inherits from my abstract class. And you can see I've implemented the various methods that are required. So you can see here, for example, I have the property getters and setters and a method that does something, which is just going to show a message box and so forth. I also have a method to math stuff, which I'm going to get back to later when we come to the optimization section. The Delphi math here just gets past a massive array of numbers, and then it does some math operations, mostly square roots, because square roots are fairly famous for being expensive math or slow math. The point here is to demonstrate some kind of mathematical operation that it's implemented in Delphi that you might want to optimize. So this is pretty simple. We have a Delphi abstract base class, and then we just inherit from it again in Delphi. Now I also have a method to create an instance of that class. Just have to remember where I put that. Here we go, create Delphi descendant. Now you notice it returns a T-abstract class. That's the abstract base class. So we're using polymorphism here to hide the fact that there's a derived class. We're just accessing via the ancestor abstract interface. So our code doesn't care how the abstract base class is implemented. And this is key. Our code doesn't care how the abstract base class is implemented. It just cares that it can call the methods that are defined and something will happen. And so here I happen to create a Delphi descendant, and it will return that. Now in this app, I have a button here called Delphi code. All this does is creates my Delphi descendant and then does stuff with it. Here is my do stuff method. You can see that it creates a large array and fills it with sort of random numbers. And it also accesses a property. This is a text property. I'm going to set it to the text set from Delphi, and then I'm going to call a method called do something. And that do something method is the one that showed a message box. So I'm going to ignore the math one for the time being, but I just want to demonstrate this right now. So if I run this, and I click the call Delphi code, you can see that we get a message box that says hello from Delphi, and the property that it's reading has the value set from Delphi. So I hope the technique here makes sense. We have an ancestor class, we derive it in Delphi where that drive class does useful stuff. And in our Delphi code, we get an instance of that, we call methods on it, free it, it's easy. Okay, so that's our model. Our model. We have a base class derived from it and call methods on it, and we saw that in Delphi. Now, due to the translation and ABI compatibility, we can do exactly the same thing in C++. We have our Delphi base class, and we can derive from it, but this time we derive from it in C++. And then we can call methods on it from Delphi. So this is all in the C++ package. You can see I've added the Delphi unit here. Because this is a .pas file, when you build the C++ package, all the Pascal units are built first before the C++ ones. And that's because the compiler automatically generates a translation of what in Delphi is the interface section of the various types and so forth, and creates a C++ header containing that information, which you can then include in your C++ code. So let's have a look at that. So this is our Delphi abstract class unit. This is the one where we defined the abstract class. Now that gets compiler translated to something that's honestly fairly ugly looking, mostly because it is compiler translated. I'm going to scroll here so you can see the key part here. But even if you don't write C++, you can probably understand the structure of this class. It's got the same properties and methods, although it's written a bit differently. Now I won't dwell on this too long, since C++ syntax is the kind of thing you can pick up from reading it or from reading a book on C++, but it basically uses squiggly braces instead, and some things are written in a different order to Delphi. For example, the virtual keyword goes at the front of the method declaration, and it's an abstract base class, a pure virtual in C++ terms, because of the equals 0 at the end, which says, hey, this method is declared, but it has no implementation. Different syntax, but it means the same thing, which is a bit of a key to the stuff I'm saying today. So what we do there is, in our actual C++ class, we have our header, and the header in C++ is the equivalent of the implementation section in Delphi. This looks a lot cleaner here, I think, because I'm just deriving from the abstract class. So again, C++ syntax is different, but I think you can probably understand that we have a class declaration. This decl spec here says that it's a Delphi style class. I'm calling it a TCPP class. It inherits from the TAbstract class, which is our Delphi class. And you can see that I have methods here, like a method do something and the method do math stuff, which are the same methods that we had in the Delphi abstract class. Now, one thing that's interesting is that in Delphi, the do math stuff methods just takes this array of single or array of float as a single parameter. Now, when it's translated to C++, most things when they're translated to C++ from Delphi come across exactly the same. So you can see here that I have a set text method, which is the setter for my property, and it has a Unicode string value, which is, again, the order of how you write the parameter values and types is different, but you have a method with one parameter, and when it's translated, you get one parameter, which is what you expect. Now, do math stuff is different. In Delphi, it had one parameter, the open array. Now, C++ doesn't have the concept of that same type of array as Delphi does, so it gets translated to a pointer to the first element, and then a second parameter of the number of elements in the array. And this is actually how it's implemented under the hood in Delphi as well. It's just that the language hides that. You don't see that. But I think this is interesting because it's because it's an example of one of the slightly unusual translations that you can get. Anyway, that's the interface in Delphi terms, or the header declaration in C++ terms. And again, I just want to emphasize here that we're doing the same thing in C++ that we did in Delphi. We're just creating a C++ class that inherits from the Delphi class. So let's move to the implementation. And in C++, instead of having interface and implementation sections of the unit, you have a header file and a C++ file. So that's what we have here. I'm just going to scroll down so you can see that we have our get text and set text methods. I'll scroll past that so that we have our do something method. And just like the Delphi one, we have something very similar where we end up calling a message box. Only this time it's going to say hello from the C++ class instead of hello from Delphi. Alrighty. Look, there's one final missing piece, which is getting the C++ class back to Delphi. Now, if you remember, when we did this in Delphi, let me scroll here, here we go. We have this method, create Delphi descendant, and that returns the T-abstract class, but it actually creates an instance of the Delphi descendant. Now we want something very similar for our C++ class. And so what we're going to do is we have a method here that is implemented in the C++ package called create CPP descendant. Now here's the Delphi equivalent of that. So function create CPP descendant returns a T-abstract class standard call, and this external keyword that this calling convention, this external keyword says that it's loaded from this particular package. We translate that, and remember that this is keeping the same API but expressing it you're in a different language, but it means exactly the same thing. That we have a method that returns a T-abstract class pointer called create CPP descendant using the standard call calling convention. And while Delphi says that we're loading it from the C++ package, we're going to say that we export it. That means it is available to be loaded. And all it does is create a new instance of our C++ class, which is the equivalent of Delphi creating a new instance of the Delphi class. Then back over in the Delphi app, you remember that we had these two buttons called Delphi code and C++ code. If we go to the C++ code, it just calls create CPP descendant. Let me show you where that's actually defined. This is the actual line of Delphi code that I showed commented out in the C++ side before. So Delphi knows about this. It knows there's a method called create CPP descendant. It knows it should load it from the CPP package. So here we just call that, and then again we pass it to the same method, do stuff that we did before, which set the property and call the do something method. Only in this case, the instance that we're going to get is our C++ class, and the do something method is going to show a message box saying hello from a C++ class. All right, let's run this and see what happens. It just takes a moment. Okay, so we have already seen this where we call Delphi code, and if I click the Delphi button, you already know what happens. It shows a message box, hello from Delphi. And then here we're doing the same thing. The second button calls C++ code, and here we get another message box saying hello from the C++ class. It shows the value of the property. That property is implemented in our C++ class, but it has the value set from Delphi because our Delphi code set it to that. And a bit of other text that I put in that just shows using some random C++ stuff. So there we are. That's the basic technique. We have the keys that you can call or that you can write Delphi code that behaves as though it's calling a method or setting a property on a Delphi class. and your Delphi code can be completely unaware it's actually implemented in C++. Now, if you have a large dev team, you may have some people on your team who don't want to learn C++, and that's fine. You just need one person who's interested, and the rest of your team doesn't need to worry about it, because the code that interacts with whatever you implement in C++ is written in Delphi. And once you can call C++ code, you can write anything you want in C++. So what we have now is the bridging mechanism. We got a C++ class, and we can write any code we want in that, in C++. So remember how at the beginning of this talk, we were talking about how different languages are good at different things. Now, C++ is good at optimization, and it's good at having a lot of open source libraries to take advantage of. So I want to have a look at both of those right now. So back to Delphi and my Delphi implementation. I have a Delphi method here. It does some math stuff. I briefly covered this before, where we pass it a very large array of numbers, and then it just does some math on each entry in the array. This is very meaningless math. I basically just wrote it because it's the kind of thing that can take some time to calculate. Basically, we want to try and optimize this using C++. Back in my Delphi code, I already showed calling the do something method. What I'm going to do now is comment that and uncomment this code instead. So I'm going to use a stopwatch to measure how long it takes to call do math stuff. And then I'm going to show a message box with that information of how many milliseconds. So let's run that right now, and we can see I have a very big array here. You can see how large it is. And so we're going to cycle through that 3 times, doing various math on it. And we're going to measure using the stopwatch how long that takes. So let's run that right now, just the Delphi side, and we can see how long it takes the Delphi code there. And this is Windows 64-bit, it's built in release mode. So I click the Delphi button, and the math items took 207 milliseconds. So 200 milliseconds to do all of that math. So the question is, can we leverage C++ and leverage, say, an open source C++ library to do better? Well, let's go to the C++ class. Now, look, first of all, I could just directly translate that to C++ as I've done here. And I think that's probably very readable because it looks fairly similar to the Delphi code. And that will already give some very good performance. But what I really want to show is not just writing C++, but using an open source C++ library, mainly for the sake of demonstrating that you can use an open source C++ library. So if I go to get it, now I have already installed a C++ library called libsimdpp. Let's just take a moment to load. Perhaps a couple of moments, I can grab a mouthful of tea. Alrighty, so loading the C++ libraries. There are quite a few here. If I scroll down, there's one here called libsimdpp, and it's a portable zero overheads, low-level C++ library, which is for math optimization. So I've already installed that, and so now I just need to show you how to use it. Installing, by the way, from Get is the same as in Delphi. You just click the install button, and it will download and install for you. Now, look, to use this library, all I need to do is include the header at the top. That in Delphi is like adding something to the users clause. Now, this particular library can optimize math to various instruction sets, like SSE2 or SSE 4.1 or AVX or AVX2 and so forth. You choose which to use by defining a macro before including the header, because the header, which is the same as using a unit in Delphi, because the header behaves differently depending on the value of this macro. Now, I've never used this library before, so it was fun experimentation. I actually found a small bug while doing this, by the way. So we should be able to define here to use, say, the AVX instruction set, which would be nice because we get some really good optimizations there. Now, unfortunately, in 11.0, we don't ship all of the headers we need to do that. There are a whole bunch of intrinsics that directly map to various assembly instructions. We're missing a couple of headers for the very advanced, very modern intrinsics like AVX. So I entered an internal bug for that, and we should hopefully ship them in 11.1. So for this demo, I'm just going to have the library optimized to SSE2, which is actually the default instruction set that we use for math in C++ Builder 64-bit anyway. And we get some very good optimization. Go ahead and try this in 11.1 when we actually do ship the other headers, and you can modify this to, say, use AVX or something like that, and see how much better we can get it. But we're going to see a huge performance increase anyway, just using this compared to the same code in Delphi. So let me scroll back down, and let me just quickly go to the Delphi implementation, just to remind you of what it did. It looped through the vector 3 times, and the first time it calculates the square root of each element of the array. The second time it squares the element of the array and then multiplies it by 2. Then the third time it does a square root again. And again, this is fairly meaningless math, just chose it because it's the kind of math that can be slow. So let's have a look at the implementation using this particular library. Now, this library is meant for using the vectorized math instruction sets like SSE and AVX and so forth. And so this translation is quite long compared to the Delphi code because the C++ library is I don't know, I guess a little abstract. It has the very basic building blocks that you use. So as I note, I haven't used this library before, so don't count on the translation being completely right. But I looked at some code samples online, and I believe it is. And what we're doing is that instead of going through the array one by one, we're going to calculate and vectorize it 4 elements at a time. So you can see here that my for loop increments by 4 instead of incrementing by 1. So every time we go through the loop, it'll increment, jump ahead by 4 instead of by 1. And each element through the loop, we have a structure here that will load 4 elements of the array, 4 floating point numbers. So we load 4 at a time. Then we call square root on it using this library's version of square root that can handle calculating that for 4 elements at a time. And then we store the result of that back in the array. And we do the same for the other operations, to square and multiply by 2, and then of course to square root again. So you can see here this library is very decomposed. It provides very basic building blocks. But the thing is, these building blocks are intended for vectorization, for operating on multiple bits of data at the same time. But you can see, though, in spite of that, that it does the same thing as the Delphi code. Alrighty, so let's run this. Let's take a moment to compile. Looks like I changed enough, it's completely rebuilding. Alrighty. By the way, I have my project set up using dependencies. so that when I try to compile or run the Delphi app, it will automatically compile the C++ package first, which is a neat feature that we have. You can just access it by right-clicking in the projects menu and accessing the dependencies item here, and you can set up the order of compilation for multiple projects, so that if one project depends on another, the first project is always built before the second one. However, so just a reminder of where we are. We have our C++ class inheriting from our Delphi abstract base class. We have some math code in that. That is a translation of our Delphi math code, and we are using an open source C++ library called libsimdpp that provides vectorization primitives that allow us to highly optimize the mathematics code. Pardon me. So just a reminder, we'll call the Delphi code 213 milliseconds. Let's call the C++ translation of that, and took 35 milliseconds. Now that's a very decent speed up. Let's say 8 or 10 times faster. All right. So what did we just see? We implemented a class in C++. Our Delphi app speaks to that C++ class as though it's Delphi through the magic of our compiler translating the declarations and the ABI magic. Now that C++ class can use any C++ at all. This is the real power of it. Once you cross that language barrier, you're not restricted to writing Delphi C++. You can write any C++ at all in your C++ class. And we used a third-party open source C++ math library. So we added C++ to our Delphi app. We used an open source C++ library, and we optimized our Delphi math code to get, let's say, about an 8 times speed up. That's really not bad. All right, so this is a new version of code from Code Rage 2016. There's the link there. I haven't pushed the new code back yet, but I will very soon. We have 20 minutes left, so let's move on to a live Q&A. I hope it was useful, and I hope to see many of you who use Delphi taking advantage of the strengths of 2 languages. Before we move on to the Q&A, just want to point out you're always welcome to email me. I read every email that I get, and I try to reply to all of them as well. But I can guarantee that if you email me, I will read it. So with that, let's move on to the Q&A.
Okay, I'm here. Sorry, trying to upload everything for next sessions.
No worries.
Question.
Well, hi again, everyone.
Hello. It's like you were just talking to us.
Yeah, amazing, isn't it?
Does mixing of Delphi and C++ does work in general too, which means under iOS, Android, macOS, and Linux, or is it only for Windows?
It works for every platform when we have a C++ compiler. So for example, we have iOS and Android 32. We don't currently have macOS. But if you have a C++ builder on that platform, then yes, this technique works on that platform. That's one of the things about C++ builder. This is how it's built. It always will work.
Now, we're also asking, is it relies on BPLs? Do you have to deploy the BPL, or is the BPL linked in, or what does that mean?
Yeah, look, in this one, I linked with the package at runtime, so you would deploy the BPL. I mean, to me, I find that cleanest. It's how I would recommend doing it. I mean, there are other ways to do that, but that's what I would recommend. So yes, you need to deploy that BPL using this technique.
Okay. So there's a question about replays. We are working to get the replays posted right as quick as we can. They should be available in perpetuity for attendees, but can't guarantee forever. So do watch them as soon as you can, but we're working our best to get them up there. We're not planning to hide them from you at some point. A lot of people commenting about how useful this is for them. That's great. Are you planning to share your source code?
I'm sorry, I was muted. Absolutely, yes. So there's an early version of the source code from 5 years ago that will get you started straight away at the link on screen. But I pulled that source code and just made some modifications to it yesterday. So I will, commit that back, push that back later today or maybe tomorrow. The only difference is that the code in 2016 used this just to show a message box, and I extended that this time to actually use another C++ library. But the technique just of jumping from Delphi to C++ by itself is already there on that link.
Yeah, it's interesting. Reprising a session you did from 2016. It's one of those things that in my mind, a lot of times I'm like, I did a session on that. I don't want to do it again. But then I find if I do it again and I add new things to it or enhance it or whatever. And then also, I mean, clearly a lot of people hadn't seen this before because they're like, oh my goodness, I've been wanting to figure this out forever. So thank you for doing this again. I appreciate it, you revisiting this for sure.
Well, it was 5 years ago, and that's half a decade, which is kind of surprising in a way. And I think as well, many people don't necessarily know how to do this. I've often got questions about people interested in doing this, but not sure where to begin. And so I pointed them to that older presentation, but I think it is a really good topic to revisit.
Yeah, agreed. It's crazy to think that 2016 was half a decade ago, and in computer years, that's like forever.
It is, yeah.
The question here, what happens if the array doesn't contain a multiple of 4 elements? Is it a buffer overflow?
Look, that's an excellent question. So this is demo code, and it doesn't handle things like that. Now, I happen to define the array so that it had a multiple of 4 elements in it, which was a little hand wavy there. The way you would actually write this is to check the size of the array and then go through and vectorize as much of it as you can. But if you have like a snippet left over of, let's say, 3 elements at the end, then you would just run normal code on those 3 elements. So you would need a bit of extra code there just to check the length and to handle that.
That's always the tricky thing with demos is not making it too complicated, but not. So Roll saying would be interested to see the C++ performance of the straightforward translation 2 without using the SSE2.
I can directly answer that. It's actually very close to the same, probably is the same. I haven't looked at the generated code. The reason is that our C++ compiler for Win64 uses SSE2. And the library that I was using, I set the macro to use SSE2, and the Clang compiler is very good at optimization, and it probably produces very similar, if not the same machine code for both. What I really want to do is to use a couple of the headers that we mistakenly don't ship in 11.0, but that, as I mentioned, I've put a internal bug report in so that we will ship them in a future release that will allow us to use things like AVX and AVX2, because those are instruction sets that we don't currently target by default, and I would be very interested in seeing the performance there. I would expect that instead of 8 times faster than Delphi, you could double that again, for example, probably.
Do reference counted parameters strings work auto-magically?
Yes, they do. So C++ Builder has full understanding of all the core Delphi types, things like, well, strings, of course, Delphi interfaces, ref counted interface, and some of the special Delphi types, things like currency or tdate time and that kind of thing. So all of those are ones that you can use in your C++ code.
So you do need both. You need Rad Studio if you want to have both Delphi and C++ Builder. I mean, I guess you could buy them individually, but I don't know if you. I don't know. You need Rad Studio, yes.
It's more expensive to buy them individually. Rad Studio is Delphi and C++. That's effectively what the product Rad Studio is. Pardon me. I'm sorry. So yes, yeah. To use C++, you need to have C++ available, and that's a Rad Studio license.
So you commented that Rad Studio can translate Delphi code to C++ automatically. Can you elaborate on that?
Sure. Well, the Delphi compiler does that actually, and you don't need C++ Builder to see that. If you have like a Delphi component, for example, you can go into the Delphi compiler settings, and there are settings there for generating C++. I call them translations here, but there's a setting where it will generate the header file, which is the API translation, but it also generates the object files that C++ needs to link against, and so forth.
But it doesn't generate all the implementation code, just the headers and the object files.
Depends what you mean by implementation code. I mean, it provides everything that you need that you can link into your C++ app to run the Delphi code. So I mean, a Delphi unit will be translated both with the header and with the compiled code. So the compiled code can, the Delphi compiled code can become part of your C++ app. Pardon me. I didn't actually show you that side in this talk. I was focusing on adding C++ to Delphi, but it's very easy. And in fact, I think it's slightly easier to add Delphi to a C++ app. In fact, that's how C++ Builder works. Every time you use a T button, that's actually written in Delphi.
So this is an interesting question. Can we do the same with Dev C++, or I guess other C++ compilers, or is this a unique to C++ Builder?
No, this is unique to C++ Builder because we have built in the compiler magic to be aware of the various Delphi types and the Delphi ABI. So you remember I spoke about the API and the ABI earlier. C++ Builder is aware of things like the Delphi class layout, and it can inherit from a Delphi class. Delphi class, a Delphi object has a bunch of extra stuff in it that a normal C++ class doesn't. C++ Builder is aware of that, and so it can inherit from a Delphi class, and we call it a Delphi style class when it's in C++. You can't do that from standard C++ compilers.
So the BPL that you used, is that standalone, or does it require the VCL, RTL, and other BPLs to be deployed with your application too?
That particular one was standalone. I mean, it just has, uses the Windows message box function, doesn't actually use any VCL in it. But of course, if you want to, you can have VCL or FireMonkey code written in C++ if that's what you want to do.
I know we Delphi developers like to have our single exe with no dependencies, but frankly, BPLs is pretty cool. Runtime BPLs is pretty cool. I've used them a few times and they're very, very useful. Rolf's asking, can I mix DLLs from Visual C or other C++s in a similar way? So not the same way, but is there some way they can use them from other C++ compilers?
Not easily. I mean, this gets back to the ABI issue. So the underlying, like under the hood, how something is implemented to be compatible. And every C++ compiler implements a different ABI. So our ABI is obviously Delphi compatible, which is different to the Visual C++ ABI, which is different to what you'll get with GCC, and so forth. So when you have anything that depends on the ABI, such as calling method on a class, they are not compatible. What is compatible is what we call plain old C, which is where you flatten everything to a C API. It's not object oriented. It doesn't use any of the things like classes or other sort of complex data types like that. It's just plain old C methods and structs. Because you can decompose and write a wrapper doing that, and then sort of wrap that back into something object-oriented if you really want to do that to access a DLL written in some other C++ compiler. Personally, I think it's a lot easier just to build it in C++ Builder. Actually, there's a question here that I saw, which is, did I misunderstand, but didn't use step by 4 in C++, but step by 1 in Delphi? And yes, that's true. That's deliberate. Because in Delphi, we're just looping through the array and doing math on every element. In C++, we were vectorizing it, where vectorization means to do multiple things at once, basically, using instruction sets that can do multiple things at once. So the code we wrote operated on 4 elements of the array at a time, and that's why we stepped by 4 through the array.
There is a few more questions here. There's one here about the Parnassus components, which you're involved in as well. I know you're very, very busy working on that in Delphi, but I don't know if you want to comment on that being available for 11.
Yeah, that is coming. And apologies for the time that's taking. We do get a few questions about that. It's a little complicated why it was all to do with our build system, and we're just reworking how they're built and how they're integrated. We should get those soon.
Yeah, there are a lot of changes with high DPI in Delphi 11. So David I saying, I seem to remember in the way past there were issues in building C++ based components and using them in Delphi. Is it easy to mix components built with Delphi and C++ in either language apps, VCL and FireMonkey, besides the obvious compiler support for different platforms?
It depends what the problems were. I'm not aware of any problems anymore, because there were 2 sets of problems that we had. Now, one was an ABI issue. I mentioned ABI a lot in this talk. But we actually had some bugs in our ABI between Delphi and C++. And that famously resulted in one particular type, like a T-Rex, I think, that sometimes had invalid data when you tried to access it. And that's been resolved ages ago. That's fixed. So the ABI is compatible. The other one was to do with Delphi style RTTI, which is generated. And in 11.0, in fact, we have revised that so that we get full Delphi style RTTI generated from the Delphi style classes. And we get C++ style RTTI generated for the Delphi style types as well. So I haven't really advertised this very much, but we did a lot of, I guess you'd call it quality work to make sure that everything is very smoothly integrated. Actually over the past few years, but like in this past release 11.0, there's a lot of stuff done under the hood to really improve that.
Yeah, David pointed out that the C++ builder compiler includes its Delphi compiler support, so you can build Delphi components, etc. Yeah, it's interesting because if you can build a C++, if you have C++ builder, correct me if I'm wrong, you can create a C++ project and then include a Pascal file that is Delphi code that you can then compile with the C++ compiler. Is that right?
Sort of. So if you have a C++ project, you can add a Pascal file. When you build your C++ project, the Delphi compiler will be invoked on that Pascal file first before any C++ files are built. And part of doing that will be to generate the header, the C++ header translation of that. And that means that your C++ code that wants to integrate Delphi can then just include that header. This is something that I didn't share in the talk because I talked about adding C++ to Delphi, not really adding Delphi to C++. But actually the GitHub link has the same GitHub link that's on screen has a demo showing this in action.
Do you have a list of favorite C++ libraries or code that would be useful or required for a Delphi developer, right? Maybe to use?
Well, that's a good question. The closest we have is that I do have an internal list of C++ libraries that we're adding to get it. And we've built that list because they're really useful libraries. So the one that I demonstrated today is one of them because it's really good for math optimization, and there are a whole bunch of others. And C++ has so many, and many of them are very easy to use with C++ Builder. You can just download them and compile them. And the C++ open source world is vast. So I have a big spreadsheet internally of the ones that we're trying to add to get it step by step. And it has, you know, graphics libraries and math libraries and, you know, algebra libraries and scientific libraries and data format libraries and all sorts of things. So that's a very non-specific answer, sorry. I'd want to pull up that spreadsheet really to give you an answer. The best I can say is there's a lot out there.
So, and a lot of those are showing up in Git, right? So that's a good place to people to look for those sort of things.
Yes, in fact, we have something like another 6 or 8 that are queued up to be added to get it sometime soon. But you don't have to use the ones in Get it. I mean, there are many libraries out there, and you know, for many of them, since we support C++ 17 on Windows, and we work a lot on being compatible with other compilers in terms of what our RTL provides and that kind of thing, it's usually pretty straightforward just to download and use one.
If an exception is thrown in C++ code, can it be caught in the calling Delphi code?
If it's a Delphi style exception, yes. Generally, it's good, you know, rule of thumb not to let exceptions pass module boundaries. So in general, you shouldn't, I mean, in any language, really, you shouldn't have a DLL that lets an exception get out. Now, of course, part of the ABI stuff is what happens with things like exception handling. So we actually have done, again, a lot of work under the hood with, you know, exception handling, and that is compatible, yes. If you have a C++ style exception that gets out, then you know, that will be exposed a little differently to Delphi, but short answer is yes.
So we do have another session starting here in a minute. I will I can start it actually, so we can run over. So
Sure.
Question here. You use system : Unicode string in C++ file instead of just Unicode string. Is this to define using C++ system Unicode string instead of a Delphi Unicode string because you're working in Delphi?
No, they're the same, well, effectively the same thing. So Delphi's string is Unicode string. Now we translate that in C++ in the system namespace. So that's why it's system : Unicode string, because it's the system namespace contains our Unicode string. Now we actually have a special header for each string type. The Unicode string is defined in uString.h. If you have a copy of C++ Builder open, you can go have a look at that. And that's a direct translation of the of the Delphi type. So it is effectively the same thing. I mean, you pass a Delphi string in on the Delphi side, and on the C++ side, it's defined as a system Unicode string. And the other way as well, by the way, if you end up passing that, you can have a Unicode string in C++ and pass that. You have a Delphi method and call that, and on the Delphi side, it'll just be a string.
If a class is created in C++, does it need to be freed in C++?
That's an excellent question. That's about memory managers. Normally you should always free where you create. Often just in code style, that's good. But when you have different modules like this, you have a package and an exe, then in many languages or setups, the exe might be able to handle your pointer to something and call a method, but it won't know how to free it. Now we have a shared memory manager that but both the exe and the package are linked against. It's our common RCL. And that means that something that's created in one can be freed in the other because it's the same memory manager that looks after the allocation and deallocation of memory. You need to be sure, of course, when you do that, that you are using the common shared memory manager, but that's how it is set up.
Yeah, I remember. Well, I guess I was doing Delphi that way, but yeah. Is Delphi or is C++ as good at stopping memory leaks as Delphi is?
Sorry, memory leaks.
Memory leaks, yes.
Yes, I mean, like canonically with Delphi, you will have a create, try, and finally free pattern with Delphi. Or for something like components, you'll have the ownership model where your component owns another and then it's responsible for freeing. C++'s pattern, I mean, you can write any C++ code you want, but in C++ you would normally use a smart pointer. I recommend looking into one called unique pointer, unique underscore PTR, unique pointer. And that takes ownership of something. And then when it goes out of scope, it will free whatever it is that it owns. So in many ways, I think C++, modern C++, is better than Delphi at preventing memory leaks. Old style C++ was a lot worse, but modern C++ with the use of those smart pointers, I think is very memory safe. Old style C++ used the new and delete keywords to create and free. And there's sort of a saying that with modern C++, you should not use those keywords in your delete. That seeing them is a bit of a code smell, because the canonical way to do things in C++ now is with smart pointers.
Not knowing C++, is it worth learning C++ or just use Delphi and the C++ available libraries?
Honestly, I think that's a matter of interest. I mean, I quite like C++, although it's a monster of a language. It's very big and very complicated, and I do not understand all of it. I don't think there's anyone who understands all of it. Maybe a few people on the C++ standards committee, but it's a complex language. I think in general it's worthwhile learning other languages just for, I mean, languages express things differently, and through that they allow you to think differently and tackle problems differently, and I think that's good as any programmer. You don't have to learn C++. You might want to use Python. You can use Python with Delphi as well. Ruby, I don't know, whatever interests you.
Yeah, people, I'm sure you get the same thing, but I get people oftentimes that are like, expect me to be like coming down, oh, C# or Java is terrible or whatever. And it's like, you know what? I think that a actual senior developer, a modern developer, is going to have multiple tools in their tool belt, and they're going to know other languages, and they're going to pick Delphi or C++ builder because they know all the other ones, and they know that that's the best one for this job. And sometimes they'll mix things together like you're talking about there as well. So it is good to learn other languages because sometimes it will influence the way you write code in your preferred language, or you'll find ways to extend it with and stuff. So yeah, absolutely agree with you. I just realized I have this exercise strap over my shoulders and it's green, and so it's translucent with the background.
Oh, really? I actually didn't notice that.
Yeah, so it's disappearing like almost completely here. This was from my physical therapy. It's one of those stretchy bands. I forgot I had it on my shoulders. I try to do some I'm sitting on an exercise ball and trying to do the things to keep, a little movement going here while I'm working.
Yeah, I had just thought it was a blue, like a strap or braces or something. Yeah, I didn't realize it was transparent to the background. That's rather cool.
I have a tie-dye shirt like David Eyes, and it has a green band in it that does the same thing. Will we be able to use GPU acceleration in applications like this? Besides, are there any studies for GPU accelerated algorithms in RAD Studio?
Look, I mean, if there's a C++ library that implements GPU acceleration, then we should be able to use it. I haven't used any myself. I mean, we haven't put any of those in Get yet. But C++ Builder can compile C++ code. So if there's one out there, use it.
Yeah, it's kind of like so there you can, like you're saying, but it's like the shaders, right? The shader code that's in FireMonkey, for example, isn't compiled the same way that Delphi code is, but it's injected into the GPU to run there. So it's a weird thing. But yeah, if you have like you said, if you have a library that uses it, GPU accelerated code, then you could certainly use that. And there are Delphi ones as well as C++ ones. It's one of those things I remember being like, oh, that's not possible. And then I saw some examples, some Delphi examples doing it. I'm like, oh, it is possible. It's a big thing to wrap your head around, but then once you start doing it, I think it's not as daunting as it appears to be. Does RAD Studio, like the IDE or the compilers or whatever, use this technique of mixing Delphi and C++ together?
Most of RAD Studio is written in Delphi, but there are small bits of C++. To actually answer that question, I need to go and have a look at them to see what technique they use. It's possible they use a different technique. So I can't directly answer because I have to go and find out. Certainly the first part of translating Delphi to C++ to create a C++ header and the object files and so forth is used very widely because that's how C++ Builder works. That's how you can use the components and buttons and so forth, because those are all, of course, written in Delphi. And when you have a C++ app that uses them, it's using the Delphi implementation that's just translated so that C++ Builder thinks it's C++.
So the next session is running. People are already over there watching it. I hate having them overlap, but at the same time, I hate leaving questions hanging if you're like really into this. So, yeah, just so everybody knows that. I mean, you already missed 9 minutes of it. If you were planning to do that, so you might have to catch the replay. Are there free libraries for Modbus or Profbus in C++ that can be consumed in Delphi?
I'm not sure what Profibus or Modbus are. I'd have to Google for that.
So I know that it says CAN bus as well. I know that there are Delphi libraries for those. I know Midtoff Software has some, both free and commercial. Well, they're free for personal use. They're used in industrial automation. Modbus is the way you talk to the controller devices in industrial automation settings. Which I assume the other ones are. CAN buses as well. So yeah. And so I'm sure there's C++ ones too. Sorry,
given we're going over
off.
time. Oh no, sorry. I was just thinking, given we're going over time, I might just scroll through the questions very quickly. There are a lot here. Just see if there's anything that we missed, because I think you've covered most of them, Jim, if not all of them.
I try to group them together, ones that are overlapping, because I realize we can't always address all of them, but yeah. So, and a lot of great comments too. A few people have shared links or comments on things. Oh, does finally support Delphi's class variables and instance of functionality?
I'll have to check that to look it up. I mean, we support class methods. I need to double check on variables. We translate, I know, 99% of Delphi syntax to C++, but I'm afraid I need to look that up to give you an answer. Let's see. There's a question here as well. For the abstract class unit, is the exe using the unit from inside the BPL? Wondering specifically in the context of the function that returns the C++ version of the class, would it not be in two separate files in a real-world application? Yes, and it actually is in two separate files. So the function that returns the C++ version of the class was declared in Delphi, but it had no implementation in Delphi. It used the external keyword to say, load this method. This method exists, but load it from the package via the external keyword. And then in the C++ package, the method was declared and implemented in C++ with a decal spec, which is a kind of tag of information for the compiler, saying to export it, that is, make it available to be loaded. And so that means the Delphi code sees that a method should exist and knows it should load it from the package, and the package contains the implementation, has it there ready to be loaded. And they sync up that way.
I'm trying to type some of these. I missed what you said there, but I assumed that people. I'm trying to do three things at once as well. So,
So question as well. Sorry, Jim, do you mind if I answer?
Go ahead. Go ahead.
There's one here. The translation of the Delphi abstract class, was that done by hand or via a utility? No, definitely not by hand. If you have to do it by hand, that's so much work and probably get something wrong. No, the utility is the Delphi compiler itself. You can pass flags -j HP something. I forget exactly. I have to look it up. Or of course in the Delphi compiler settings in your project, and it will translate the header and cause the Delphi compiler to emit the C++ object files and static library and so forth. Whatever it is that you need. So short answer is done by utility, and that utility is the Delphi compiler itself. Let's see. I think that's about it. Yeah, the
I
question
will
log doesn't have
share
any
the
questions
question
for quite a
log with
while.
you later. So,
Sure.
oh, go ahead. Sorry.
I was just saying the question log hasn't had any new questions for 3 minutes now. So I think we're probably almost there. If you do have any further questions, maybe you can write them in now and we'll answer. And of course, my email's on the screen as well. Please feel free to contact about anything. It doesn't have to be about this topic.
Oh, OpenCL. I think isn't OpenCL. I feel like I saw something about OpenCL recently. I'm thinking OpenCV. OpenCL. Is there OpenCL support for C++ Builder?
I don't think we've tested it. I know it's a fairly complex library, and I'm sure with something like that you should be able to compile it. Although there might be tweaks you have to make with something that big and complex. We haven't tried it ourselves, but if you want to use it, I think C++ Builder should be able to handle it. You do tend to find that with some of those very big, very complex libraries, sometimes, I mean, you can have hundreds of thousands of lines of code, and sometimes in there'll be something that you need to tweak or change or modify. I've actually done talks on that as well, on how to use a random C++ library with C++ Builder. In general, because every compiler and every every C++ compiler and every C++ platform has these things that are very slightly different to each other, even though the language is standardized. There are often things that are different. For example, Visual C++ has a few extensions and real RTL methods that others don't, and so forth. And we put a lot of work into being compatible with everything, actually. Occasionally we find something where we're not, and then we go and implement that. And it's usually pretty straightforward to work around. For something the size of OpenCL, just because of its size and complexity, I would expect that you'll have to run into something, but it should be straightforward to fix and to use.
All right, well, let's go ahead and go. Thank you so much, David, for this, for all you do behind the scenes and to make C++ Builder and Delphi Ride Studio the great, fantastic tools that they are.
You're welcome. Well, thanks very much. And I really hope this is useful and interesting to everyone watching. And I hope that you'll be able to leverage it and add some C++ to your Delphi app for some useful situation that suits your software.
Awesome. Yeah, thank you. Okay.
All right.
Take care.
Thanks, Jim. Thanks, everyone, for watching. Have a good day.
Thanks. Bye, everybody.